Okay, let's take a look at our first example of ANOVA. The number of farms in thousands per state found in 3 sections of the country are listed below. Test the claim at alpha equals 0.05 that the mean number of farms is the same across these 3 geographic regions. So what we've done here is we've collected data from 15 different states. 5 states on the western, 5 states in the middle, and 5 states on the eastern parts of the country. And we found the number of farms in each of these. And we're wondering, is there a difference in the means between these? So remember, ANOVA, that's going to be our test that we're using when we're trying to study differences in means of more than 2 groups. So our null hypothesis in this case is going to be mu sub E is equal to mu sub M, which is equal to mu sub W. So I'm using the subscripts to indicate these groups. And then my alternative hypothesis is that at least one of these means is different than the others. So we're saying at least one of these means is going to be different than the others. So when we figure out the type of test we're using or the description of how we choose our test, the first thing that we can indicate is that we are looking at means. Now what clues us in is that the mean number of farms, we're wondering, is that different or is that the same? And we have more than 2 groups. So if ever we're looking at means with more than 2 groups, this immediately tells us that we want to use our ANOVA test. So when we go back to our calculator, we can turn that on. We can press stat. We're going to enter our data into our lists. So we enter all of this information over here into our lists. Then we can press stat, go over to the right, go to tests, and then go to the very bottom. So I just press the up arrow to go to the bottom, and that leads us to ANOVA. We press enter, and because we entered our lists, our data into the list L1, L2, L3, we need to tell the calculator those are the lists we're pulling from. So you press the second button, and then above the number 1, you see L1. You're trying to get to that. So once you press 1, you see L1 appears. Then we're trying to enter in list 2, so we press the second button, and then the 2 button, because L2 is in yellow above it, comma, which is next to the parentheses. Press the second button, press the button 3, close those parentheses, and press enter. Now you get a whole bunch of data that appears, but you see that there's this factor, there's this error group. If you study more of ANOVA and understand more of the behind the scenes with it, you'll understand where are these coming from. What's the process of how ANOVA is giving us some type of statistical claims. But right now, we're just going to focus on the top 2 numbers. So our first number is our test statistic. So our test statistic in this case is going to be F is equal to 5.858. And then our p-value we see is equal to 0.01678. Now, the test statistic, as a note, this is F because remember we said that ANOVA is using an F distribution. So T distributions, you have T's, normal distribution, you use Z's. So our test statistic is an F value. So now we make our final conclusions. We notice that our p-value is going to be less than alpha. So since our p-value, which is equal to 0.01678, is less than 0.05, which is our alpha, we reject the null hypothesis. So we reject the null hypothesis. There is sufficient evidence to believe at least one of these means is different from the others. Now remember, the alternative hypothesis just says at least one of them is different. We don't know which one is different. We don't know, is the eastern one different than the middle and the western? Is the middle one the one that's different? We don't know. We'd have to do additional testing. So all the ANOVA test tells us is that at least one of these is different from the others. And there we go. That's exactly what it looks like. So I'm going to create another video after this that uses something besides the calculator as a different way, because I know some of you maybe don't have ANOVA capabilities on your calculator, so I'd like to make sure you can still do ANOVA testing.